Hi there, Alex Linde here from AI and Power Labs, and I'm here to talk about how to build a scalable AI agent platform and how we use decades of experience from building large-scale SaaS deployments into building an AI enterprise-ready AI and agent platform. What's in this video then? First, I want to talk a little bit about why we founded AI and Power Labs, and then a little bit, and then about the API first perspective we used when implementing this AI agent platform. Touch a little bit on the human user interfaces options, and then the technical walkthrough or the main purpose of this video. So why AI Power Labs then? Well, we're working on a number of AI projects for the past 10 years, and we discovered that several of these projects was difficult to execute because of the cost of the AI platform itself. Got to be substantial. In some cases, the equivalent on having human resources running the processes. So we decided to try to do something about it and build a AI platform from scratch by ourselves. And our goal with this was build something significantly cheaper by making it very cost efficient, very spend a lot of time on how the platform executes and how efficient it uses the CPU and the GPU and the memory, and how it scales to make it significantly cheaper to run. We also added a very humble license to this to make it a cost efficient or a total cost of ownership quite low for having this platform compared to anybody else. We made the platform that's enterprise ready. It's designed for enterprises from day one, with regards to reliability, scalability, and security. And of course, if you have a large development team, you can do this yourself, but it will take you a couple of years, and then you have to maintain it. And our goal is then to give you a very efficient platform that we spent a few years on building that is very reasonably priced and very stable and secure to run. We made it compatible with OpenAI endpoints, so if you have an existing implementation towards OpenAI or different vendors following a standard, you can just repoint your interfaces to endpoints to our solution, and it will just, seamlessly and effortlessly transition. We spent a lot of efforts making it possible to create agents without the UI or and making it easy to embed it into your business applications. We also spent a lot of time making it as environmentally friendly as possible. That means that we use CPU instead of GPU, and we focused a lot, as I talked about before, on how the application scales and threads to make the footprint or the energy requirements needed to run the platform as low as possible. And that, as you know, there's a substantial energy required to run an AI agent system or a generative AI system today. We made the system with the API first. So we make all the APIs, and then for some areas we create UIs, and most of these UIs we provide as open source, so that you can extend it or adapt it to your own needs. And the API consists the possibility to embed assistance with RAG or generative AI support directly into your existing applications through these APIs. You can also embed complete agents in your applications, performing tasks across your application through the APIs. You can train and create and build these agents in the APIs as well. And you can embed machine learning into your data through these APIs. We have some human interface options. We provide out of the box a few possibilities for, as you see here, a classic chat interface that you can interact with the agent and the assistants through a chat interface. There are also speech to text, text to speech ways of interacting with the system. These are provided, as open source. You can download them from our GitHub and adapt them to your needs, or use them as there are standards as you see here, and set your colors to it and start using it. If you haven't seen our video around how to use these kind of tools to build an AI agent without a single line of code that we did earlier, have a look at that, please, to go into more details on that area. Now, there are more resources. You can go to our website, and there's a GitHub, and there's a documentation site, of course. Now, to the main focus of this presentation, how did we build this platform? What's the architecture behind it? And we start by looking from a logical perspective. What's in the platform? In the AL Studio, the main thing is that you build an AI agent. You can build one or many, and a network of agents that interact with each other inside the platform. The platform also contains a large language model, and in addition to that, a RAG system for where you can load your company knowledge from scraping websites or uploading documents, and you can do this at intervals or automatically if you want, and load your data into different indexes in this that will then be embedded into the system and it enables a RAG search with both hybrid search and semantic search, keyword search, and a very nice re-ranker. We have built a code interpreter, meaning it's easy for the system to interact with code. And we also have spent a lot of time creating a very good implementation of function calling concept. A function calling concept is the concept where you let the AI understand it's time to go from generic answer to executing a business process, and it makes AI understand that this business process, you need to gather some data like your name, the products you want to buy, and the address you want it delivered to, and your credit cards and such. And when you have that, you can execute a business process towards a CRM system, for instance, order something or send an invoice for something, or an ERP system where you can make an order for a certain product and have it delivered to your home address and also pay for it, of course, if you have that kind of process. This process, this function calling could also encompass the control of transaction concept so that you make sure that you roll the whole transaction through with steps across several systems if you want. So very nice implementation of function calling. It's independent of the large language model. There's a lot of function callings that varies quite a lot among the large language models vendors, how good or if they have support for function calling. We made one standard that works across all major vendors of large language models. For the large language models itself, we embed most major large language models like Llama 3 or 4 from Facebook, or Mistral or DeepSeek, depending on the use case, you can choose from them. And normally, a new large language model is in our platform a couple of weeks after its release from one of these vendors that we monitor and support. And we don't create large language models ourselves. We make some tuning to them to tune their execution time and tune, and you can set a lot of parameters when you execute towards them in the agent system. Of course, on the other side here, we have the different UI options that I talked about before, but you don't need a UI. You can interact with through voice, of course, but you can also have the system either execute by itself on intervals or on certain conditions, or with timers, and you can have it react to different signals like a temperature signal or a incoming mail or an SMS message or whatever you want to react to from an external system. Let's look more a little bit towards the architecture of the system behind this then. So if you look at this architecture itself, it's a container-based architecture. It's very easy to install in Kubernetes environment or in a Docker environment where you can have your orchestrations, and you just download it and instantiate it as pods in the Kubernetes, for instance. On the front end here, you have a load balancer, and all of this, of course, you can host yourself. And the load balancer, and then it will take care of traffic, incoming traffic, and put it towards the next endpoint. Then we have the central here is the AI Studio server. You build your agents and you build your configuration up. Everything is persisted towards a high availability Postgres, where you can scale out all of these components. Of course, you can have one studio server or 100 studio servers. You can have one Postgres or 100 Postgres. In addition to the studio server, then you have a number of containers that are GPU enabled, but you don't have to execute them on GPU. The only thing you have to execute on GPU is the large language model. For some cases, you might want to do transcription on the GPU, depending on if you really need real-time transcription. Otherwise, we have a very good implementation of Whisper for transcription that can run on CPU with very high quality and very high performance. Each of these could be one or many. Just you can have it react to, utilization of CPU or memory or disk and have them instantiate more of themselves, and that system will then discover that and make use of it. If you go through this, then of these separate components, we have a val key, which basically is a distributed cache. If you have 100 studio servers running, there's some information that need to be synchronized for them to be able to execute reliable across each other. Then they can use the distributed cache to store the information that states that they need to be aware of, for instance. We have a translation could be broken out as a separate service. Of course, you can use the LLM to do translation, but for some use cases where you have a lot of translation or very large translation tasks that you want to do on a regular basis, you can put it in a different container. And the transcription is a very nice implementation of Whisper that of course can scale out. It can run both on CPU and GPU, but depending on your use cases and depending on that will have a cost effect. So it's based on to balance performance to what your real requirements are. For the the embeddings is also a separate container that's where you store your mathematical representation of the semantic language that you have loaded from your knowledge into your indexes. And then you have the large language model. On top of this, then you have to make this platform enterprise ready, we have support for the open telemetry standard. So if you have an open telemetry surveillance system in your data center, that will just plug into that one. If you don't have any open telemetry, we have a simpler system also for surveillance if you need that. In addition, there is for enterprises, you want to know what's going on in your AI system, and then we have an LLM observability component that you can use to interact with the system and see what the AI is doing and how it's doing it and how it's executing inside the studio server and how that interacts with the large language models and the embeddings and such. Yeah, if you look into a little more detail, we have tried to be very compliant with the market leaders on how to interact with large language models, and we follow as great examples, very compliant with their model and their standards. So no matter what kind of client you have already today, if you have implemented towards the OpenAI standard and use their endpoints or any other endpoints, you can just migrate it over to this AI in Power Lab Studio, and it will just work out of the box. No matter what large language model you might have on the back then. So if you run with Mistral or Llama 3, then there won't be any difference to the OpenAI compliance. If we zoom in a little bit more and go into components in the system and how they execute, we are very compliant there as well. You act through what is the OpenAI compliant interface, and behind the scenes, then we will just validate the data and what's coming in, how is it corresponding to what we need, and then there's a very nice cache so that if you have frequently same kind of questions that generic, you can see can cache answers in a specific to a specific query. When you go into tooling or function calling, no matter how you go through this, how you gather the customer data, and then the AI will understand and how they need to execute towards the business system. That is very compliant with how OpenAI does it, no matter what LLM you're using on the other side. So if you use the DeepSeek or Mistral, it will still act in the same way. And it will log then and modify the request to the LLM so it fits the LLM that you're using. So very compatible, easy to implement towards. Well, that was basically what we wanted to talk to you about today, and I hope you find it interesting. And please comment if you want. And thank you for listening.